I'm Anil Kumar. Welcome to my series on speed and time graphs. In this video, we'll have three examples and we'll understand a strategy to read such graphs and then answer the questions. So let me plot two diagrams here on speed and time, and then we'll talk about them. So when I say speed and time, that means on one axis, independent variable is going to be time, right? So we'll take time on the x-axis, which is the independent variable, t, and then speed, let's say v for speed or velocity along the y-axis. Now you have to be very careful about the units. Let us say here, let's say we have time in seconds and velocity in meters per second, right? And here let's take velocity in kilometers per hour, and let's say this time is in hours. So let us choose a graph where an object starts from the origin place, right? Moves for some time, relaxes, that means it is going at a constant speed, and then again the velocity increases. Right? Let's take a graph like this, where let us say that the values for the velocities are given to us. Let's say this is 10 and we have 20 here somewhere, and that is 30 meters per second. And let's say these time intervals, which we just plotted approximately, let's say this is 2, this is 5, and this is 7, right? So we're just considering these points. Now, if you look into this graph, how do we read the graph? So we see that an object starts from rest, so that is at origin. It increases the speed gradually at a constant rate for first 2 seconds, then travels at a constant speed for another 3 seconds, right? And then goes faster, increases at a constant rate once again. Now, what we are saying constant rate is defined by the slope of these tangents, right? So definitely we do have a story here from speed and time graph. Now the question comes, what will slope of tangent at any point represent? Now let's say from O to A, let's call this A, B, and C. Right? So from O to A, what is the rate of change of velocity? Slope of the tangent will be acceleration. We are saying rate of change of speed, which is equal to acceleration. So here, acceleration from O to A is the change in velocity over change in time. It is change in velocity over change in time. So in this case, the change in velocity is 10 minus 0, right? 10 minus 0 over time, which is 2 minus 0. 2 minus 0. So 10 divided by 2 is 5 meters per second square. Since velocity is in meters per second, time is in seconds also. So it becomes 5 meters per second square. So we see that the acceleration at this time is 5 meters per second square. And from A to B, since it is 10, so it is 10 minus 10 over 5 minus 2. Numerator is 0, so acceleration is 0. However, from B to C, the acceleration is higher. So let's calculate acceleration from B to C, which will be 30 minus 10 over 7 minus 5. So which will be 20 over 2. That gives us 10 meters per second square. So it goes much faster in this region from 5 to 7 seconds, as you can clearly see, right? So this part here, what will the slope of tangent at any point represent? Slope represents acceleration, right? Rate of change of velocity. Now we have how to find total distance. Now total distance is found by measuring the area under the curve, right? So If I want to find total distance traveled in the 7 seconds, I will have to find the area under this curve. Is that clear to you? Normally we'll have a trapezoid, or we will have triangle or rectangles whose area can be easily calculated, right? So here you can see this is a triangle. So in this triangle, area will be half of base into height. You would also treat this as a trapezoid. So you could have two trapezoids. For example, this could be one trapezoid. Do you see that? This could be one trapezoid. And then we have this four-sided figure. So we have two trapezoids. Let's say T1 and T2. So that will be faster way of calculating the area. So the area for a trapezoid T1 will be, add these two. So this is like horizontal is seconds for us. So it is 0 to 5 is 5 seconds plus 2 to 5 is 3 seconds. This is 3, right? So 3 seconds. So this is in seconds, correct? We're going to multiply this seconds by the height, in this case, which is 10, right? Which is 10 meters per second, right? Meters per second. And we are going to divide this by 2. Clearly, what you see as far as the units are concerned, seconds will cancel, meters will be left. So that is area of first, right? We can calculate this area, which is equals to 5 plus 3 is 8, and 8 times half is 4, 4 times 10 is 40. So we have 40 meters as this area. Now similarly, we can find what is the area for the second one, right? So in this particular case, we have the distance between the two as from 5 to 7, which is 2, right? So we have these two are parallel sides. Remember this now. These two are parallel sides. So it is 10 and 30, correct? So we have now 10 plus 30, right? Times the height. Height is 2 seconds now. Divide by 2, right? So these two cancel. We have 40 again, correct? So the total area, let's write total area. So distance is equals to 40 plus 40, which is 80 meters, right? So we get area of 80 meters, which represents the distance. So how do you find total distance? Total distance is area under the curve. Is that clear? Now, last question here is how to calculate average velocity. Now, average velocity is ratio of distance and time, right? So that is how we'll find average velocity, which is ratio of distance over time. That is average velocity. So in our case, average velocity will be what? Average velocity will be equal to total distance is 80 divided by total time is 7. Is it okay? So dividing that, we get our distance 7 times 1 and then 10, 7 times 1, 30, 7 times 4, 28, 20. So let's say 7.4 velocity in meters per second. Is that clear to you? So that is how we do all the calculations. Perfect. So I hope the steps are absolutely clear. Now, I will provide you another graph to explore, and in this case you may have to write down the acceleration at different intervals, distance traveled, and average velocity. Does make sense to you? So let us say this time an object starts from a particular point and it is approaching, right, and it stops for some time, and then again it gets back to the starting point, right? That is what it says, starting point. So let us say this distance here, we're talking about kilometers per hour. Let's say that is 5 kilometers, right? And it takes about let's say 3 hours to travel up to, this is be, let's say 2 hours, right? So it covers that much of distance in kilometers. And then let's say this time is 6 and that is 8 for us, right, in hours. So it is a journey of 8 hours in which the object travels 5 with the speed of, starts with the speed of 5 kilometers per hour, and it kind of reaches, and that becomes 0, right? So that becomes the whole curve, right? So distance, if the velocity is gradually decreasing, it is constant at some time, then further decreases. Now here it is 0, right? So it stops here. So you are trying to find, in this case, what is the rate of change or acceleration at different intervals. These are the 3 intervals. And also, what is going to be the distance traveled and what is going to be the average velocity for the whole journey of 8 hours. Okay. So let this be your test question. Now after that, I'll attach here 3 other practice multiple choice questions for you. Feel free to go through them, try to understand the concepts. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. We'll now consider speed and time graph. Here is a velocity versus time graph which we are going to analyze and answer the given questions. Before we begin, it's important to note that acceleration is gradient or slope of speed time graph. So at any point, if I have to find acceleration, I need to find rate of change of velocity with time, right? So we could also write acceleration A as equal to rate of change of velocity with time, right? So that is kind of important to understand. Acceleration can be positive or negative. For example, here we have a slope which is going upwards, it will be positive, on this side it will be negative. It could be 0 also. Now distance traveled is area under the speed and time graph. So if you are given speed and time or velocity and time graph, you can always find distance traveled by calculating the area. Now to calculate the area, you can add area of triangles with rectangle, or you could find area of a trapezoid. So in this case, either of these formulas can be used. Now the question for you is, find the acceleration at t equals to 5 seconds. This is with respect to the diagram given to us. Velocity is in meters per second, time is in seconds. So find acceleration at t equals to 5 seconds, and B is find total distance traveled. That means from 0 to 8 seconds, correct? And the third question here is part C, find the average velocity for the whole journey. So let's begin answering them. As far as the acceleration is concerned, part A, we know acceleration A at t equals to 5 is equal to, so here at 5, what is the slope? At 5, we see that the curve is horizontal, right? So the slope here is horizontal. So horizontal means 0, right? So there is no rate of change of velocity here. So it is equal to 0. Units will be meters per second square, right? So that becomes the answer. Now let's do part B, which is find total distance traveled. Now total distance traveled will be area under this velocity time graph. So we need to calculate the area. So if you know the formula for trapezoid, that would be better to use. Otherwise, you could use some of these 2 triangles and the rectangle to find the area. Is that clear to you? So I'm just giving you time to calculate, and then you should check with my solution. So it is area under the curve, right, which is VT graph. So this is the trapezoid where the one side is 3 seconds, 1, 2, 3. So this is 3 seconds, correct? The other side here is 8 seconds. So the formula of area under this curve is equals to sum of these 2 sides. Normally we write A plus B times the height, right? So this height. Now this height is 30 meters per second, right? Times the height over 2, correct? Substituting these values, what do we get? 3 plus 8, Now this unit 3 plus 8 is better to write it in seconds. So this is seconds. As far as height is concerned, it is 30. The units are meters per second, correct? And we are going to divide this by 2. So units also, you can see that seconds and seconds cancel. So you get units in meters, correct? So let's calculate this value. So we get 3 plus 8 as 11. And 30 divided by 2 is 15, correct? So 11 times 5 is 55. 11 times 1 is 11. Adding 5, we get 165. Units, as you can see, is in meters. Right? So that becomes the distance traveled during these 8 seconds, correct? Now let's do part C, which is find the average velocity for the whole journey. Now the whole journey, whatever we're talking about, is basically from t, which is greater than equal to 0 and less than equals to 8, right? So the time taken is 8 seconds, right? So average velocity is always equal to total distance over total time. So in our case, total distance we just calculated, which is 165 meters, and total time is 8 seconds, correct? So let's divide. So 8 goes 2 times. So it's 16, 5, 20. 0.48 is 8 times 6. Then we again get 20. So 8 times 2 and then 5 meters per second, right? So that becomes the average velocity. We could always round this to one decimal place. We could write this as 20.7 meters per second. Is that clear? So that is how we could provide the answer. Sometimes we also say this answer is to three significant figures, right? So 20.7 meters per second. So I hope the steps are absolutely clear. So whenever you are given speed time or velocity time, we could have this one the same thing, or velocity time, right? In that case, acceleration is the gradient of the slope of this curve, and distance is area under the curve. That helps to find the answers. I hope. So here the question is based on the figure given to you. So we have shown velocity and time, velocity in meters per second, time in seconds. Based on this, we have 3 questions. You can always pause the video, answer these questions, and then look into my suggestions. The very first one is find acceleration at t equals to 7 seconds. B is find total distance traveled in first 8 seconds. And C is find average velocity for the whole journey. So let's see how to answer them one by one. So part A is to calculate the acceleration. So acceleration is rate of change, correct? So acceleration at t equals to 7 seconds. So at t equals to 7, from the graph, we can see that the point is right there. Now the slope at this point is, you can do rise over run, correct, to find the slope. So acceleration basically is rate of change so we could do this difference of v values. So on this scale, we can use the point. This is 20, 30. So each is going by 5 units. So this is 35, correct? So 35 over this is 15. So using these points, we get this as 35 minus 15, and this is in meters per second, over the time difference, which is 8 minus 6, right? So 8 minus 6 in seconds, right? So we get meters per second square as our units. So that becomes 20 over 2, right? 20 over 2, which is 10 meters per second square. So that becomes our answer for part A. Clear? B. We need to find total distance. Now total distance is area. So to find area, we could divide this into 3 portions, right? So rather you could do 3 or 4. You could use area of a trapezoid, or we could do like this. Right? So let's do it in 4 portions. So we'll find area of each unit. So area of 1, area of 2. You can use this trapezoid as such and then find the area, or you can say, well, A3 and A4. No harm, right? So let's find the area. So area of portion 1, which is triangle, will be half of, base is 3 units, so half of 3, and the height is 15, right? So half of 3 times 15 plus. This is a rectangle which is from 3 to 6, so it is 1, 2, 3 units wide, and here it is 15 units in velocity, right? So it is 3 times 15 plus, we could have this as a rectangle again, 2 by 15, right? So 2 times 15, and then we will add the area of the triangle, which is half of, base is 2 units, and the height is from here to there, we calculate this to be 20, right? Times 20, correct? So let's figure this out. So, okay, some simplifications. Okay, so we have 45 over 2. Let's write down 45 over 2 plus this is 45. That one is 2 cancels. Sorry, this is 2 times 15, which is 30. Here, these 2 cancels, we have 20 plus 20, right? So these are the 4 areas. We can combine them and write down our answer. So it is 20 and 30 is 50 plus 40 is 95, and this is, okay, 22.5, right? So let's do like this, 22.5 plus 50 and 40, 95, okay, 95 is okay. So that gives you 0.5, 5 and 2 is 7, 9 and 2 is 11, correct? Distance, meters. So we get our answer as 117.5 meters. C. We need to find average velocity for the whole journey. Now average velocity is ratio of distance over time, correct? So in this case, the total distance was measured as 117.5, and we'll divide this by the time taken, which is 8, correct? So we can get the velocity. So 8 times 1 is 18, 8, and then we get 337. So 8 times 4 is 32, and that gives you 55. 8 times 7 is 57, so we can say approximately 14.7 meters per second. Is that clear to you? So that is how we could round it and write approximate answer in meters per second, correct? So I hope these steps are absolutely clear. Rate of change is the acceleration, distance is the area under the curve, and average velocity is total distance over total time. Here we have 2 parts. Part A is find m. So in this velocity versus time graph, velocity in meters per second, time in seconds, we are given path of an object, right? Question is find m if the total distance traveled is 315 meters. So total distance is the area. Perfect. So we are given the area under this curve, and the question is find m. So basically you have to find the height of this triangle when you know the area. So I hope the concept is clear. Perfect. You can now pause the video, answer this question, and then look into my suggestions. Part B is find acceleration at t equals to 5. So at t equals to 5, which is this point, you have to find the acceleration. Correct? So you can always pause this video, answer, and then look into my suggestions. Okay, so let's begin with part A, where we have to find total distance. So total distance, as you know, is area under the curve. This is a triangle, so the area under the curve is half of base times height. So that will give us the height, correct? But we are given the distance, which is 315 meters. So we'll use this. And as far as the base is concerned, so this is 7. So it is 7 seconds from 0 to 7. So this is 7 seconds is the units. As far as height is concerned, it is m, and it is in meters per second. Okay. So now from here, m will be what? Let's take care of the units. These two cancel, and so what we have, the units match, correct, perfectly fine. And from here we can find what m is. So m will be equal to, let's cross multiply, so it will be 2 times 315 over 7, right? So that should be the value of m. Correct? So now dividing by 7, 7 times, let's do this, or you could just multiply and then divide, either way. So let's divide first by 7. 7 times 4 is 28, and then we have 28, and we have 35. So 35 goes 5 times. So from here we get m as equal to 90. So we use the units meters per second, so that has to be, that is correct, right? So we get this value as 90. So we know the m value here is 90. So that is part A. So we get m equals to 90 meters per second. Clear? Now we need to find acceleration at this point. That is part B. Acceleration at this point will be rate of change, right? So at this point, rate of change will be what? T equals to 5. So we can consider these 2 points. So if we consider these 2 points, then change in this value, which is y value, is rate of change of velocity over rate of change of time. The velocity goes from 0 to 90, so the rate of change is 0 to 90. However, it actually comes down, you see, 90 to 0. So it should be negative, right? Since it is actually decreasing from 90 to 0. And as far as time is concerned, it increases from 0 to 7, so it is 7. So that becomes the acceleration. It is negative. Units will be meters per second square, right? So which is equal to, dividing by 7, we get negative. 7 times 1, 20. So 7 times 6, 7 times 2 is 14. Just a minute. So minus 7 times 1, and 7 times 2 is 14. Then it is 63. So times 8 will be 50. And 7 times 7 meters per second square, right? Which you could approximate to minus 12.9 meters per second square. Is it clear? So that is how you could find acceleration at a point in the given graph. So I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great.